everyone. Welcome to today's webinar where we will be exploring why AGV and AMR deployments fail and what you can do to build an effective operation. My name is Ellie Allen Baith and I'm a content marketing manager here at Flexware. Before I introduce today's panelists, I have just a couple quick housekeeping notes for you. First, if you have any questions throughout today's presentation, feel free to drop those in the questions tab of your toolbar. If it's applicable to our question set that we have today, we'll answer it. And if not, we'll do that at the end of today's presentation. Also, today's session is being recorded, and we'll make that recording available to you shortly after we wrap up our session today. Now that that's out of the way, I'd like to introduce our panelists. I am joined today by Glenn Guernsey, Bryce Bucher, Bharat Nair, and Brian Wheat. Glenn is the Chief Engineer at JR Automation, and he has over 25 years of experience in material handling. He has a wealth of knowledge in automation, control systems, material handling system design, and integration. Bryce is the Vice President of Products at Flexware, and he has over 30 years of experience spanning product management, systems integration, business intelligence, and he oversees Flexware's intralogistics orchestration platform, Lift. Bharat is the Director of Enterprise Solutions at Flexware. He has decades of hands-on experience designing, deploying, and supporting automation systems across distribution, manufacturing, and 3PL environments globally. And Brian is Product Manager of Lift. He has over 25 years of experience working with innovative hardware and software solutions. He will also serve as today's moderator. So Brian, I'll go ahead and hand it over to you to get us started.
Thanks, Ellie. As Ellie mentioned, today we're going to be digging into a topic that's becoming increasingly more important across manufacturing and warehousing. And that is why AMR and AGV deployments fail, or at least fail to deliver the ROI and operational transformation that the companies expected when they deployed them. And as we take a closer look at these failures, you're going to see that in many cases the robots technically work, the fleet moves, the missions execute, but what's missing is some of the expected throughput and performance levels that promised in the business cases. So today we're going to explore what's really behind these issues, and more importantly, what you can do about it from a technical, operational, and organizational standpoint. So let's go ahead and dive right in. So Glenn, we're going to start with you. Let's first, for the folks that are newer to automation and maybe these terms, AMR and AGV, they're almost used interchangeably. Can we start by clarifying the difference and more importantly, maybe how that difference matters operationally?
Yeah, certainly. So AGVs, automated guided vehicles, these are generally things that go on a fixed path. They've been around for years, whether that fixed path is on the floor, such as a magnetic tape, a rail, QR code, something that says this is where it's going to go, and it's going to always go in those distances, or excuse me, those directed paths. An AMR, which is autonomous mobile robot, an AMR maps the area and can make its own decisions and dynamically change its path. If something gets in the way, they can drive around it. It can have different ways to get from point A to point B, and if during that path it's blocked, it may have to go back and try a different path. So autonomous mobile robots are ones that can, again, change their paths. Where you get the difference is if you've got something like an assembly line, you need to go from station 1 to station 2, then to station 3. You don't want it ever to get anywhere outside of that. That's an AGV. That's something you're going to go and stay on that path. But let's take that same assembly line and say that, hey, sometimes I want you to skip station 2, go around to 3, and then go back to station 7 before you come back to 2. But most of the time I want to go this way. Or you've got a lot of humans involved, you've got a lot of things where it dynamically changes and you have to be able to drive around. That's more of an AMR type situation. Things have changed a little bit in recent years, that AGVs, even though they are still staying on their path, they can now, AGVs can also do some mapping And there are areas which you can set up in the path to say, if something gets in your way, you're allowing them to get off the path before they get back onto the path. So AGVs are getting close, and the two of them are sort of molding together, and they're almost, like you said, they can be used simultaneously. Both of them can be used, and one for the other. This does seem to be, too, one of these areas where some people get pretty passionate about it, that they get pretty upset. If you call their AGV and AMR and vice versa, if you call their AMR and AGV, they get pretty upset about it. But I think altogether they're mobile robots, whether it's an AGV, whether it's an AMR, they're all still mobile robots.
Right. Yeah, that makes good sense. And I'll probably just use the term mobile robots from here on out, just to merge the two, like you say. So where do mobile robots really, where are they creating the most operational value today? I mean, you've got all sorts of places in the manufacturing distribution, but where are those mobile robots kind of settling in at to prove themselves as being valuable?
Well, the biggest thing that's making a difference is when you have a repeatable path, something where it's got to go from here to there and maybe to here to several there's, but it's got to do it again and again and again. That's really where you get the most value for them. Now, you've got, again, we talked about an assembly line. Maybe in an assembly, you've got AGVs would be used to go from different stations. But if you've got parts that have to come from a warehouse to be delivered to the assembly line, then that's also another really good use of it. And then if you've got trash that has to be picked up in certain areas, but all gets placed to a certain area to be dumped, trash bins or something along those lines, that's also another area that they get to be used. Whenever you've got long runs, like in warehouses, you've got things that finished goods and you've got to take it to the warehouse. That's a really good example of where these things are being used to pick up from the end of the assembly line, take it to where it's got to be stored, or take it over to a shipping dock and shipping area. And anytime you've got your building pallets, the pallet's done, you want to take it to wrapping, then you want to take it from wrapping to shipping. There's another perfect example of where they're being used and being used very successfully.
Let me add a little bit to that too, Brian, if you don't mind. So yeah, what Glenn's describing are all the classic material movement cases, which is true. That is where you typically start with when you look at mobile robotics. What we're also seeing now as companies start their digital transformation journeys to lights out unattended operations, which most companies are looking as their end goal, we're starting to see also the use of mobile robots when it comes to machine tending, loading materials onto and off of equipment, any interaction that's required at the line side in order to be able to kind of get that last mile of automation done. We're seeing mobile robots start to be used for that. Cobots on top of mobile robots, other unique sort of mobile robots that can help with that machine tending operations. We're starting to see that as well. Probably not your starting point on your journey, but certainly one of the things you're going to have to take into consideration.
Exactly. And I think this is one area that you're going to see over the next few years, some changes or some improvements. Right now, with the cobot, you're very limited in how much weight you can move with that cobot on the end of an AMR. So with the end of arm tool that's got to be used and whatever you've got, you're sort of limited. But we're seeing every year, if you will, improvements in that where they're getting to be able to move more and maybe be able to move it a little bit better. But it's a perfect example of you've got machines where you're paying people to just stay there and all they do is take this part out, put a blank in, close the door. That's a perfect example for where a cobot on an AMR could also do that.
Great, that's great. Right, let's shift our focus to the kind of the buying process, which you know, a lot of these deployments look successful during the demo phase. So you got vendors, they're promoting the robot, it can do all these things, and maybe even at go live, initial go live, or during the pilot test. But 6 months later, the operation's underperforming. Why does that happen, and what kind of things happen during the demo phase that don't translate well 6 months later?
Yeah, that's a great question, and something very often overlooked when companies start their journey towards intralogistics automation, whether it be it just be AMR or cobots with AMRs, as Brian and Glenn were talking about. And I would beg to argue that sometimes some facilities won't even take 6 months for the performance to start degrading or issues to start popping up. And there are many reasons for it, and we'll kind of get into several of them over the next hour or during this conversation today. But the primary challenge that most of these environments face is the fact that a lot of these demos are the demos, and the go live environment is a very clean, pristine, controlled environment, right? Whether it's in the AGVs, AMRs, or the mobile robots themselves operating, or the integrations being demonstrated through, through a proxy or a dummy integration capability. And everything looks nice as it's running through its demo environment or in a pre-shipment testing environment. But once you hit the go live and once the production starts, the facilities are very different and the operations are very different. So if there are even small variables or variabilities in the process, small hiccups in the integration or handling of the integration, be it synchronous or asynchronous data exchange, that gets amplified, right? I mean, automation amplifies your broken process. It doesn't fix it. So very often, companies embark on this automation journey with the intent of let's automate this material flow. But there are so many human decisions that are made during that material flow process, and we'll get into a lot of that in the next hour here, that are ignored when the automation is designed in a classroom or a demo environment type settings, which then translates to real challenges and exposure to a lot of these workarounds and a lot of this exception handling that was not well thought out, or was thought of but not designed properly into the automation solution. So there's a lot of these challenges that gets ignored up front or put on the side burner in terms of expediency for going live. So that's my take based on my interaction with a lot of the customers over the decades. So
yeah, I get it. Yeah, like you say, a lot of things are glossed over in the demo. They want to paint the best picture, the most rosy picture, and they're not oftentimes addressing some of the more critical gaps or those issues. So Bryce, let's zero in on that. We hear robots are putting in place. They buy the robots, they get them out there, but they never really get to an automated system. So what's one of the missing pieces here? What happens? What's the gap between having a robot in place and having an automated system that is functioning as designed?
So it maybe starts with considering how a typical customer will approach these projects, and it's pretty obvious that you want to start by the physical aspect of your project. So you know that you're going to want to automate some sort of process, probably a material movement process. You know what the materials look like that you want to move, the shape, the size. You know whether or not they need to be picked up from the floor or dropped onto a rack or conveyed onto a conveyor. So those are all the physical aspects, and you're going to go out and you're going to select your vendor based on what robot or piece of equipment can physically perform the duties that you're looking for it to perform. And you want to think you're almost done at that point because you've selected the right vendor. Now it's time to implement that piece of equipment or hardware. But that's really where the problems tend to start to be uncovered, and they start. And this is getting into a problem space we've been talking about for years now, which now has a name associated with it, which is orchestration. It's no coincidence, any of us that attended Modex recently, it's like every booth had orchestration on, orchestrate this, orchestrate that. And it's because the market is starting to become educated in the real problem with these solutions is that they cannot be solved by hardware alone. These robots are very intelligent in navigating their environment, mapping the facility, figuring out routing plans. Their fleet management software is super sophisticated in helping avoid obstacles, divert paths, etc., make sure they're not running into one another. But the problem is that's still a contained system that needs to be integrated with a much larger set of systems and people in order to be able to achieve success. So there's this digital aspect to these projects. So above and beyond the hardware or the physical aspects, you have to be, if you're going to kind of achieve this concept of what we started to refer to as physical AI, you have to add this intelligence layer that allows your robots and equipment to be able to interpret their physical environment. And they're going to have to do that at least as good or better than the human-centric operations which they're intended to duplicate and eventually replace. So you have to think about how are we doing these processes today? So we tend to like to run customers through a current state versus future state analysis. And when you do that, it's very important that when you're mapping the current state, you map out your process, but you don't stop at just, oh, I need to pick up a material from the warehouse, I need to deliver it to equipment A, and I'm done. Because it is much more complex than that. And you think through, how does a human do that today? There are probably a dozen or more different micro decisions that human is making as they are navigating that movement. And success depends on them being able to make all those decisions in real time. And there's a bunch of examples we could talk through here. But simple example is, let's say that your typical process is you're going to stage materials in a particular area of your warehouse, and that's where your material handlers are going to pick it up from. Well, a human on a fork truck can go to that area. They know what material is requested. They know the line it's going to. They have some history built up in their mind about what that material looks like, size, shape, maybe color when it comes to containers. And they can identify it very quickly. A robot's not going to know that. It has no idea what it's really even looking for. It doesn't have the sensors in order to be able to, usually visualize the area. So we need to be very specific about dropping that in a location that it knows to go pick from. That's one example. There's a bunch of others. You get to the line itself, maybe the location where the robot is supposed to drop it is occupied. Well, what do you do next with that thing? The robot's just going to stop because it doesn't have the data or the information it needs to make the next decision. A human, on the other hand, can do that very quickly. You could communicate with the operator at the equipment. The operator can say, just, put it over there for now, I'll get it later. Or the operator can say, hold on for 2 minutes because I'm about to run this material off, and then you can load it in. Or the operator or the forklift operator might know that material is also being ran on the next line over. So maybe I can just go drop it over there. There's a bunch of outcomes here, but the human's going to be very good at making those decisions. A robot will not be very good at that. So when we talk about orchestration, we're talking about adding this layer of intelligence that allows you to be able to accumulate all this information that you need in order to make all these real-time decisions. And in order to do that, you need connectivity. You need connectivity with all these systems that currently house that information. You need to be able to gather information from the real-time physical environment, and you need to merge those together into an intelligence layer. This is a gap that has not been met very well up to this point and is standing in the way of a lot of these projects succeeding.
Yeah, so I hear what you're saying. So orchestration requires intelligence, operational intelligence, context to allow for direction and these missions for the robots to do what they're supposed to do and help them, if we can use that term, treat them like people, help them do what they need to do with some context involved. And you mentioned, connectivity, and obviously to provide that context or that operational intelligence, we hear the word integration out there. Can you maybe elaborate on how the integration problems are kind of discovered too late in production, that, integration with the warehouse management system, the manufacturing execution system, ERP systems, that's all really important because these robots need more than just a direction on going from point A to B. They need a lot more context, and those systems that are already in place provide that. Can you elaborate a little more on that, Bryce?
Yeah, Sure, and this is a classic case of where connectivity does not necessarily just equal success, and a lot of customers would like to think that. A vendor will tell them that they have, let's say, an API for their software. That API is meant to be able to communicate with any external system that it needs to, and they think, okay, I'm done. This system that I'm buying has an API. I know that my WMS system and MES system also has an API. I've got APIs everywhere. I should be good. But that's really only where it starts, because you still need to be able to communicate effectively between those systems. And so you need something in the middle to be able to do protocol transformations, connectivity, the correct connectivity between the two different systems. Maybe they don't even speak the same languages or use the same protocols. So that is where this orchestration layer becomes so important, because it's this agnostic layer that allows you to be able to truly connect all these systems together, but also be able to steward the movement of data and information effectively between all these systems. So, and it goes even beyond that, because the integration itself sometimes is much more complex than what customers might think going in. A classic case here is just a simple handoff from a mobile robot to a conveyor. It looks, when it's working correctly, it looks so smooth and natural, you just assume it's simple under the hood, but really it is quite complex underneath. The robot has to be able to navigate up to the conveyor, has to be able to orient itself so it's physically aligned. Then there has to be handshaking between the robot and the conveyor in order to be able to turn the conveyor on the equipment side. That has to be done in a safe and effective manner. That requires there to be space available to receive the new load. Stop gates have to be dropped, etc. Once that starts moving, then the robot can start moving its conveyor. And then once the handoff is complete, the conveyors have to stop on each side. There's a bunch of back and forth that happen there. The handshaking is actually quite complex, even though the movement itself seems to be fairly straightforward. So I think our advice is, don't sleep on the underlying complexity when it comes to integration. It might be a lot more than you bargained for. And if that piece doesn't work, that might sacrifice the entire project, because you haven't been able to fully automate things all the way through to the equipment. So think about all those integration points, walk through that current state. How does it work? How do I want it to work in the future? And can all the systems that I'm including together do that in an orchestrated manner?
Brian, you're on
Ryan,
mute.
you're muted
Brian?
for some reason.
I had to cough there. That's why that.
I did the exact same thing. At least I remember to turn it. Normally I don't.
Yeah. Appreciate the insight there. So yeah, we've got orchestration, we've got integration. Let's talk about scaling a little bit. A lot of folks start out with either a proof of concept, or they start small and they start to scale. Bharat, can you kind of give us some insights into what people underestimate when the robot traffic itself starts to become an engineering problem? What happens as fleets scale and you add more robots and more robots?
Yeah, no, I think, thank you, Brian. And I think Bryce elaborated on this with some really cool examples in the previous conversations there about, the forklift operator, and contrasting the forklift operator versus a robot coming to pick up a pallet in a staging area. That's a great example. But where I'm going with this is the fact that, in a factory floor, humans improvise, right? And what I mean by that is the visual system, right? The eyes and ears of the operators drive the operation or keep the operation humming. So if there are obstructions on the path, if there are challenges that they run into, they talk to each other, they cut through the line, they walk around the obstruction. So they have means, tribal knowledge, if you may, or experiential capabilities to work around and improvise and get past the current situations. On the contrary, robots obey rules, right? I mean, they are designed to operate in a consistent, repeatable, sustainable, or reliable and safe manner. So the robots can't go around objects unless it's a safe environment. To what Glenn said in the opening remark about AMRs versus AGVs, there are technologies that are designed specifically to operate in certain conditions, in certain scenarios. So what happens is when there are obstructions on the factory floor, when people leave carts around, when people don't put pallets the right way, to Bryce's example, in a staging location, the robots don't know what to do. The robots don't know how to address that situation, and they wait to either for the obstructions to be removed or addressed, or a human intervention. Well, what happens at that time when you scale up the robot? If it's one robot, it's fine, it's just waiting there. But if you have 10 robots, and say, for example, it's 5 robots doing 2 different workflows each, and they share path, and one of the robots or one of the workflows has an obstruction in its path, or blocked on a turn because of some some cart or something jutting out in the pathway, it's going to block everything behind it. So now there is a cascading effect of multiple robots stacking up behind each other, multiple mobile robots, I should say, stacking up behind each other on the path. And that cascading effect really becomes a big challenge. Now, complicating this is oftentimes you realize that a same supplier may not, or let me put it differently, more and more end customers, manufacturing and warehousing operations, are moving to multi-supplier AMRs and AGVs, right? So with specific use case scenarios, and these operate with different fleet managers, so they don't talk to each other either, right? So now the interoperability problem escalates and scales up significantly when you scale up the number of robots. So there's a whole series of challenges that come into play when you scale up a robot that you may not have thought of when you did your pilot run with 1 or 2 robots, or you did a pilot run in one corner of the facility, and now you're scaling up to the rest of the facility by adding more robots, adding more workflows, and incorporating more work cells into the operations to I think it was Bryce who mentioned earlier, to this vision of unattended operations, right? So there are numerous integration challenges, operational challenges, process challenges, people challenges that needs to be thought out as you scale from a small pilot in one corner of the building to the rest of the facility and up the value chain.
Yeah. Glenn, I saw you nod. Oh, go ahead. Go ahead, Bryce.
I want to add one thing to what Bharat was saying too, and he hinted at this, that you're most likely not going to be able to source all of your robots from one vendor in order to be able to satisfy all of your use cases. So you're going to get into this state where you have multiple vendors having to interoperate together in, oh, my light just turned off, in the same physical space. And you would think, because of how sophisticated these systems are, that they should operate safely and effectively together. And that's actually not entirely true. They will be able to detect the presence of one another and stop, but most likely that's not going to happen until they violate one or the other's safety sensors. And then you've got what's called a deadlock situation, where they're both stopped waiting for the other one to move. And that can be crippling from a downtime standpoint. So this introduces another problem space. We call this problem space interoperability, and you need some way to be able to have those two systems speak to each other, communicate with each other, and operate in a way that is totally efficient and effective. There's lots of ways to go about doing this, but most likely each of those vendors themselves is not going to provide any solution that's going to help you. You're going to have to work with some sort of third-party system to be able to do that for you.
Yep.
And that's why I was shaking my head, is because, yeah, if what you get, I've dealt with people where they started their path, they've introduced some AMRs to their system, but either one, the company that they started with doesn't make what they want, or 2, the company doesn't exist anymore because it was a startup and they're not around. And now you're adding this other fleet manager to your system, or you've got to have a totally different process, and the 2 have to operate in the same area. You're going to have that, and that's where you definitely need the software to act as that traffic cop to prevent this, because otherwise you're going to be needing a lot of humans trying to get things, AMRs, moving out of the way to get finish their path.
Yeah. Yeah, and I think that's exactly what we're seeing here. You know, facilities, especially these material movement areas, are designed for people, not robots. And so,
Exactly.
you know, as you bring up more robots into the fold, you know, you've got these shared aisles and you've got all this stuff where robots now have to consider not only themselves and other robots, but people, because intermixed in all this is also people, right?
Yeah.
We haven't gone fully lights out yet.
Exactly. And I've said this to several people. I said the mobile robots are very polite. They are going to stop and they're not going to force their way. And if you start intermixing where you've got people, whether you've got other drivers, whether you've got whatever it is that's going to interfere with them, they've got protocols. They've got safety things that says, I can't move. And they'll get to the point where it may even violate something where it's now an emergency stop or a stop where now a human does have to get there and clear it and say it's okay to move. And you need systems that are smart enough to prevent that from happening.
Yeah, yeah, excellent. So we've got orchestration, we've got integration requirements, we've got interoperability, shared spaces that these robots have to go on. You know, this leads us to the fact that, you know, in manual operations, you can walk the floor, you can see these things and instantly see problems, but automation changes kind of that dynamic. And this is, you know, we hear also this term of visualization. I think that's part of one of the things that's emerging when you try to automate is visualization from a single pane of glass, seeing what's going on and being called to alerts. Bryce, maybe you can elaborate on a little bit about why visualization has become so important with the introduction of mobile robots, especially in material movement.
We talked earlier about how what we really need is a set of software and systems and hardware working together as one overall system or solution. So you've got this very complex combination of solutions that's coming together as a holistic system. But if you don't have visibility into how this system is operating, you're going to be kind of working from behind. So I really kind of see there's three aspects to visibility here. So first off, you need the ability to provide some operational insight. So this is for your operations folks that are trying to run their plant, and they need to be able to have insight into how things are running. So we've got this complex intralogistics automation system. So you need visibility. Where are my robots? What are they carrying? What is the status? Which ones are down? Which one's moving? How in general is my system running? So that's number one. Number two, you need the ability to troubleshoot and diagnose problems as they come up because problems will inherently happen. Systems are not perfect. They cannot program themselves out of everything that comes up. You will have to get humans involved in the loop here. And when that happens, you want to be able to raise things. You want to raise the right information to the right people at the right time as quickly as possible. Visibility helps you do that. It helps you pinpoint exactly where is my problem. You can click into that. What is the source of that problem? What are the underlying systems involved? And where, trace it all back to that root cause analysis as quickly as possible. That's going to allow you to be able to get things back up and running. If you piece these solutions together in more of a bespoke manner, you end up with a lot of custom solutions that are kind of black box designed and don't have any visibility into them. And the problem with that is Happy Path might work just fine. As soon as you have an exception, you have no idea where the problem is. You might have to get some technician with some credentials involved. You might have to start digging into log files. It becomes a very long process to surface the right data and to be able to get back to root cause. So you really want something that software-wise that allows you to be able to get to that root cause analysis as quickly as possible. So that's number two. And then number three, you want to be able to do data-driven insights and analysis on the system over the course of time. So you need to be able to accumulate all this data that's coming in. You need to be able to accumulate that, visualize it back to the proper personnel in the forms of dashboards, reports, analytics, etc., because you want to be able to improve over the course of time And this also helps drive you towards more predictive analytics and predictive monitoring and maintenance, which is going to help you be more proactive moving forward. So this thing is like a flywheel. And once you get it moving, you want to keep it spinning faster and faster and faster. But you need all those components together in order to be able to get there.
Yeah, I see that. And certainly the introduction of, as we mentioned previously, about multi-fleets. A lot of these vendors, they provide what's called fleet management software, and with their individual vision is just the vendor themselves. And so one of the powerful things is to bring all those multi-vendors into a single pane of glass, so you can actually track all of them at once and understand, where they're headed and how they interact with each other. Yeah, so I get that. I can see how visualization is so important.
Yeah, I just want to add one more thing, Brian and Bryce, to what Bryce said, right? I mean, so it's great, and you're absolutely right. When there are fleets of robots, or especially multiple different fleets from different suppliers involved, we need a single pane of glass. But it's not just the visualization of the mobile robots, it's also everything else that's within the facility from a single pane of glass perspective as it relates to automation. So the real-time visualization is truly an encapsulation. It's almost like a digital twin of your factory floor with real-time inputs from all of the automation components that can talk to a single pane of glass, right? So it's great to have the moving robots displayed, indicating, whether it's carrying a load, whether it's carrying empty, what load is it carrying, where is it going. But it's also important to know which, static robot or which work cell or which palletizer or which cell is working or not operational, and for what reasons, right? So that way we can, to what Bryce said, we can diagnose the root cause and apply corrective actions. So if there is a line down, why send material to that? Why not reroute that material to another line that's required? Because we never know when lines go down, whether it's maintenance issue or parts issue or whatever the case might be. So I just wanted to kind of expand the vision of that real-time visualization to include other elements of a facility automation system. So.
Yeah, that's a great elaboration. Thanks for drilling in on that. And Bharat, maybe we can take a look at, oftentimes robot deployments end up really being an operational redesign project. I mean, you're introducing robots, they tend to be focused on technology, but how much is it actually process redesign? How much of the process do you have to reconsider when you introduce a mobile robot into the mix?
I'll beg to challenge that some operations leadership might question the need to redesign the process, or a process complete redesign to introduce automation, right? That's a massive undertaking. But what typically the errors that happen is they try to automate what's already there, right? So your standard operating procedures for manual material flow, for manual interactions between robots and work cells, or racks or staging areas with human material handlers or operators, are different and needs to be different than your operating procedures when robots are involved, whether the robots are involved in entire operation or part of it, right? So there is a lot of redesign or rethinking that's required, maybe not for the entire process for the material flow, but some aspects of the material flow, some aspects of that interaction, where previously there was a human, but now there is a robot. And to one of the examples that Bryce gave about a human loading a fixed cell conveyor, he or she can jiggle the load and get it just aligned to load into the machine, but a robot cannot do that. So a robot, the handshake has to be accurate, the exchange needs to be precise, right? So those are things that needs to be thought of from an operating procedure perspective, from an integration perspective. And then there might be need to redesign the material flow, because as I think it was you, Brian, who said the facilities today, or at least the brownfield facilities that I walked in and out of, are not entirely designed for robot especially mobile robot operation in today's day and age. So when you start introducing mobile robots, you got to rethink the material flow design within the facility. You need to start setting out aisles that may be dedicated to robot, or maybe a shared aisle, but you have to partition those aisles. You may have to, previously a operator or a forklift operator could go bi-directional to drop off loads, whereas now the robot has to go all one way around. So there are those things that needs to be rethought about, redesigned, and more importantly, where you're eliminating the human touch, you need to bring in change management. You need to bring in training. You need to bring in, I want to say HR and training, because you want to make sure that you're communicating as to not eliminating the person's job, but augmenting it with automation, accelerating the throughput or efficiency there from a safety point of view, from a throughput point of view. So there's a lot of elements that goes into it that needs to be thought out. Where I've seen some challenges is oftentimes an organization or a team incorporate has a mandate to bring in automation, and they go and pick a plant and say, okay, here's the pilot, here's the technology, we're going to come in and we're going to get this done. And they forget about understanding how that particular facility operates, what the constraints are, what the challenges are, what the integration requirements are. And that runs into some of the challenges we talked about earlier, where initially the pilot or that automation program looks great, but a few months into it, it goes sideways and starts or does not deliver the ROI or the business case that was outlined at the beginning of it. So there is a lot of rethinking that needs to be done. It may not involve redesign, but it certainly involves rethinking integration, rethinking training, rethinking human interaction, rethinking human machine interface, and so on and so forth.
I hear you. And I think one of the more uncomfortable realities is that a lot of operators never fully buy into the deployment. So bringing a people factor into the design and maybe process redesign to bring the operators into the fold so they cooperate and help facilitate the robots. That's going to be.
There's another thing I wanted to bring up. It's this is a real world example that I lived through, right? And I over the decades that I've been in this industry, we have this mantra called measurement drives behavior. And what that translates to on the factory floor is the production folks or the production leaders are measured to produce certain quantities of products, whether it be widgets or cars or components or whatever it is, at a certain per piece, per component price point. And then automation comes in, or robots come in, thanks to different groups, or doesn't have the plant buy-in. And now you start seeing some challenges with regards to the robots taking its own time to achieve or come there, or maybe stalled, or maybe having problems. And then the people start workarounds because they are measured to put those products out, not to support the robot operations or fix the robot operation so it can deliver the last mile thing, right? So I've seen situations where the robot with the material is literally like 3 feet, 4 feet away with some cart sticking out and it's stalled. All the guy had to do was go in and push the cart in, and the robot would have moved in with the material. But no, he just, brings in a material or something else from another side and continues the operation. He ignores the robot completely. So there are those kind of the measurement drives behavior, and this is why KPIs and the metrics are very important to very early on to establish, both at the automation layer but also at the operational layer, so that there's alignment between how the metrics are measured.
Yeah, very good. I hear you. We've got a question from one of our audience's members. Fernando's got a question. I'll just read the question to you, and then you guys feel free to jump in. I think this question revolves around infrastructure, which I think is a very interesting question, because there's all these things that need to be in place to support this whole idea of more robots. So here's his question. Bryce talks about visibility and data-driven. I believe the components need a reliable network. Most certainly. Most commercial people do not talk about the need for a reliable wireless network. Can you talk about the requirement for delivering working, reliable solutions? I don't know if we can, how much detail we can get there, but certainly we've all seen that. We've seen gaps in the wireless spotting and the robots fail. I don't know who wants to jump in on that one.
Well, maybe I can start and others can jump in, but I mean, I was just on site at a customer last week and the concept of Wi-Fi was brought up for the project and the customer said, oh, we've got Wi-Fi everywhere. And then like it was a period and they were ready to move on to the next part of the conversation. And any of us that have done these projects know that that is only the start of the conversation. So it involves, and this probably goes to other topics we want to talk about too, the engagement of the customer and getting all proper groups from the customer involved in projects. So you have to get IT involved here. There'll be a site assessment and surveys and things like that involved in assessing the technical viability of your existing infrastructure by your vendor, but it also it involves the coordination internally within the customer as well to make sure that you are putting the right pieces in place. Everything is adhering to standards. You've got a separation as you need it between your OT network, your IT network. If you have Wi-Fi already on the shop floor, you might need a separate segregated Wi-Fi for your robots. These are all just concepts that have to be, they cannot be ignored and they have to be addressed, and you have to do it early on. You can't push that to later parts of the project because what you might find is that there is some technical infrastructure piece that is standing in your way of success and it's just too high of a price tag to hit your ROI number. So you need to find that out sooner rather than later. But I'll let the other guys weigh in here too.
No, I agree completely. And it's not like there's a standard, oh, this is all you need and you've got one answer. I think this is something that it's very specific in different sites and what the challenges are and what you see. Some sites might be none. Very rarely does that happen, but maybe there's no challenge at all. And then other sites, there are some things where you may either have dead spots or the bandwidth or whatever, but these are things that you do have to take into consideration before you do any of them. Yeah, there's going to be a survey. You've got to find out. But if the survey comes back and says there's problems, who's going to take care of that problem? Who's responsible? Make sure, like Bryce says, you've got to get the right people involved. This isn't just somebody from engineering calls procurement and they have the whole thing happen. You've got to get everybody involved. The operations, you've got to get the IT people involved so they all understand this is what we're doing and this is how we're going to do it, so everybody can buy into that and get their parts taken care of.
There's one other thing I want to add to what both of you said, and I think Bryce, you alluded to it, and I just want to, this is from a real life example from many years ago where we did do the Wi-Fi survey and everything looked good, and for the mobile robot, and we did deploy. I think we deployed a bunch of them, and to our comments earlier, during the pilot phase and the go live phase, it was looking very good, and everything was looking good. And we went from phase 1 to phase 2 to phase 3 to phase 4. The whole facility was divided into 4 quadrants. Long story short, once all of the phases went live, we failed to take into consideration all of the Wi-Fi demand from the facility infrastructure, like RFIDs, like scanners, like stationary printers, like all of those other things. And when these robots, when they were working in single environments, that didn't matter much, but when the whole environment came up, and there was all of this Wi-Fi traffic from all these facility side integration, things came to a screeching halt. So to Bryce's point, there may be a need to assess and dedicate a separate bandwidth or a separate network for the robots, separate from the facility infrastructure. But those are all things that needs to be coming out very early on during the design and concept stages.
Yeah, I hear you. I think a lot of times you introduce mobile robots and they just uncover. It's not until deployment they uncover those weak spots in the Wi-Fi or things like that. Oftentimes, That's why visibility is so important and bringing data in. You can have heat maps in your visibility so you see these repeating patterns and where robots are failing in certain areas. It's not obvious, but if you can track those common areas where there's either congestion or failures, that's where visibility becomes so important to identify root causes.
Exactly.
Absolutely.
Yeah, this topic came up the other day, and I want to interject it here. I don't know if we're primed for this, but this idea of robot or battery management. It's one of those things where all these robots require battery power, and people, can go for hours and hours, and maybe just need a drink of water. Maybe they got a snack on hand, but robots, they have to go back and recharge. Oftentimes, the fleet or the vendor have somewhat limited solutions on how they do that. But I think what I heard was that it's much more complicated than that. That there needs to be some context and intelligence built around recharging these batteries so they don't fail mid-mission. Do you guys have any insights onto that and how we can help solve that problem, which is
Well,
becoming more and more problematic?
this is one of those areas that's really important up front, and this has to do with getting the right partner, getting somebody that can look at this too. But yeah, you have to look at the whole big picture. You're not just this thing. You've got to look at what are they going to do, how often are they going to do it, what kind of number of missions, because you can size a fleet to do the job, but if you don't take into full consideration how much charging time and what has to happen with that, your fleet size could be too small. Or if you're trying to do just opportunity charging, but you've got certain things that exceptions, let's say, that happen continuously, you still got to keep in mind those charging things. So it's something that requires the knowledge to look at this and say, here's what we're going to do, here's how many we're going to need. And yeah, you may only need 3 mobile robots to do your automation, but because of your shift and what they're doing and how long, you actually need to buy 5 or you need to buy 6, because you've got to have some that are charging, you've got to have some that are available to do that in the amount of time. There are also systems out there, but these are still emerging, where they're charging on the fly. In other words, they've got areas where everything drives over the path. It doesn't always work for all of them. Those are just some things that can help, where it's inductive charging that doesn't have to necessarily get to it. But these are all things of looking for the right hardware, looking at every one of the aspects of the automation to come up with the correct solution, as opposed to trying to fit this product into the solution, looking at everything and to say, this is the right product to go with. If that kind of makes sense, is to look at it from that standpoint, as opposed to, here's what I got to work with, how do I fit it into your situation? It's look at the situation, what's the right product and right solution for that. And charging and keeping these things charged is a major part of that.
Let me add one thing to that too, and just extend that concept. So everything that Glenn just said is absolutely correct. We are starting to find an even more complex underlying problem surface, even beyond the basic charging methodology and sizing your fleet correctly, et cetera. And that is, most of these fleet management softwares do have charging logic, and it tends to be fairly sophisticated and work pretty well. But there are exceptions that we're seeing happen in real world implementations that are outside the bounds of what they can handle. And one of those just came up with a customer this week, where it was a very complex set of movements for an AMR, where one of the stages of the process required it to sit idle indefinitely until it was allowed to move forward based on the downstream part of the process. And the charging strategy allowed it to start the mission, but it ran below its threshold during the mission and did not have enough to complete it. So it was sent by the fleet manager to the charger mid-mission, abandoning its task entirely. And no matter how the customers worked with the fleet management software, could not figure out a way to do it within the fleet manager software. So they've asked us, Flexware, with our lift platform, because we have all this operational data that is being accumulated based on the fact that we're dispatching the missions to the fleet manager. We have enough information and data to be able to predict how much charge it's going to take to be able to complete a mission based on prior instances of that mission. So it's an example of, if you have the right data, you can make the right decisions. If you don't, you can't. So, and it's as simple as that. And the only way you can get all the data you need is to be able to connect all these systems together, aggregate all this stuff into this intelligence layer. We call this orchestration. And then you're going to be able to have a chance of succeeding on these very far edge cases that come up. But these edge cases will come up, guys. We have seen this time and time again. They always come up, and they always end up being the thing that either makes the project succeed or fail. If you can't figure out a path forward and a way through it, you might end up failing right there on something you didn't even see coming. So this is a great example of that.
Yeah.
It is a great example, and it just goes, I mean, when you think about battery management, I mean, everybody's going to say, oh, we got, yeah, it recharges, but that can add such a success factor into everything and can be so impactful. And I think it's such a great example of the small little detail that becomes a big deal to that ROI or that reaching maximum productivity. We've got another question coming in. Peter asks, he says, there's a lot of talk about AMR congestion on the floor. We kind of mentioned that. You previously mentioned robots, nice robots stopping for operators, right? That's a great example. Are there any industry metrics on how disruptive this congestion is, e.g., for example, downtime hit or OEE hit? And I think one of the things I want to elaborate on this question, I think it's a great question, that, you know, this politeness, and sometimes it's related to safety, right? There's a reason why robots are polite,
Yes.
is because they're trying to be safe. And there is a balance between safety and productivity that have to be met on the shop floor because you're interacting with folks. I don't know if you guys have any insights on, you know, whether there's any KPIs or, you know, what downtime is hit on this idea that robots are polite.
I don't. Go ahead.
Go ahead, Glenn. I'll join.
What I was going to say is I want to go to the safety thing. One thing that I explain a lot is essentially, if the way to think of it is the mobile robot's going to go the speed and, you know, what it can do based on, if you had a wide open area and it can go as fast as it needed to go, it's going to go that fast. But as you narrow up that area, or as something starts to get closer and closer, it's going to change its operation. So it has to be able to stop in time, and it's always going to be able to try to stop safely. So the closer you get, the slower it has to go, because it has to make that stop. It has to have enough time to slow down and stop. So it is a safety thing, which is why, quote, they're polite, because they see something coming, they're going to start to get slower and slower the closer it gets, until finally, if it gets too close, now it's way within its safety and it's got to stop. And now that's more of a human interaction there. But yes, it is a safety thing. But as far as the KPIs, I don't know, Bryce, do you guys have any of those?
Yeah, the only thing I was going to add there was, to your point, Glenn, and Peter, that's a great question, but there are no hard and fast rules of how we establish a KPI, because each facility is different, each workflow is different, each path is different, right? So that goes back to my comment earlier about when you're introducing mobile robots within a facility, you really need to walk the floor, walk the paths, and design how you want to be positioning the path and the travel path or the travel direction for each of the robot fleets, whether it's you know, the single fleet or multi-fleet. And then depending upon the congestion on the factory floor, like depends on how many people are crossing the aisles or operating there, there may be a need to add additional vehicles in terms of efficiency so that it doesn't affect the efficiency. But to Glenn's point, robots, you know, they all follow or have to follow the ANSI standards, and they do stop for safety reasons at all times, right? So how you balance the stoppages is through proper training, path planning, 5S compliance, training, and operator ownership to drive basically what they need to do, right? So it's basically a combination of multiple things, and we can certainly have a deep dive conversation on that, but it's always facility specific and operational specific. I see Ellie jump online.
We're down to our last minute here. So I want to thank the panelists. Again, I think we heard orchestration, visualization, process redesign, interoperability, integration, all exception handling, all these things need to be adopted into a single strategy. So hopefully this has been a benefit for everyone. Ellie, I'll pass it back to you to close us out.
Awesome. Thank you, Brian, and thank you to all of our panelists, and thank you for joining us today. Hope you are taking away some actionable insights back to your team. If you'd like some further guidance on how to successfully deploy AGVs and AMRs, or if you want to dive deeper into any of the topics that we discussed today, please reach out to us. You can reach out to me directly at ellie.allenbaith@flexware.com, or you can reply to the email I'll be sending you shortly with the recording link, and we can get you connected with the right expert to answer any of your questions and help you build out an effective strategy. Also, keep an eye out in that email for a white paper that goes into a framework for how to deploy AGV and AMRs effectively. So keep a lookout for that, and thank you, and have a great rest of your day.
Thank you.
Thank you. Bye-bye.